Today in lesson nucleus, we are going to discuss relationship between radius of a nucleus and atomic mass of the element. So for that we assume that nucleus is of spherical shape. Naturally we find that liquids are of spherical shape when they are free from any external force. Small droplet of liquid, when mass is very small, gravitational force becomes very negligible and the liquid acquires spherical shape. So in our nucleus, we know that nuclear force is largest. When you compare the forces, natural forces, gravitational force, electric force, all these forces, like by comparing gravitational force with that of electric force of two charged particles, of two protons. So you will find that gravitational constant 6.67 into 10 to the power minus 11 into masses of protons. So when you will put mass of proton, 1.67 into 10 to the power minus 11, 10 to the power minus 27 and whole square, because gravitational force is equal to G m1 m2, 1 times mass of proton, then again mass of proton divided by r square. And for same distance, when you will write the value of electric force, this will be equal to K, that is 9 into 10 to the power 9 into charge on protons, and this is 1.6 into 10 to the power minus 19 whole square divided by r square. So on simplification you will find the ratio force of gravitation divided by electric force. This comes equal to 1:10 to the power 36. Here you find that electric force is very large. Now when you find ratio of all the three forces under consideration, force gravitational, force electric and force nuclear force, then the ratio will become equal to 1:10 to the power 36 is to 10 to the power 38. This nuclear force is very strong. So the other forces before this nuclear forces is negligible. Now when negligible force acts on any nucleus, it should remain in spherical shape. So we assume that a nucleus is of spherical shape, and it is found that the radius of a nucleus is equal to some constant R0 times 1/3 the power of atomic mass. Here R is equal to R0, a power 1 upon 3. This is the relationship between radius of a nucleus and atomic mass of the nucleus. Here R0 is a constant and its value is equal to 1.2 into 10 to the power minus 15 meter. In femtometer you can write 1.2 femtometer. So you find that radius of a nucleus is proportional to 1/3 the power of atomic mass. When you draw a graph between radius and atomic mass by taking radius along any one axis and 1/3 of atomic mass along the other axis, it should be a straight line as they are directly proportional to each other. So here we know that nucleus is of spherical shape. Now we do not know how the nucleons are arranged inside any nucleus. We do not know that whether they are evenly distributed protons and neutrons, one proton, one neutron, one neutron, one proton, how they are placed there inside nucleus, we do not know. But we can find the density of these nucleons. Okay, so let us find the density of nucleons. Density of nucleons within a nucleus. We know that density is equal to mass per unit volume. And mass of the nucleons is actually mass of protons plus mass of neutrons. So here you can write mass of proton plus mass of neutron divided by volume. And volume of any sphere we know 4/3 pi r cube. So the density, say it is rho, it will be equal to complete mass. Here, if you assume that mass of proton is nearly equal to mass of neutron, you know it is equal to 1.67 into 10 to the power minus 27. A slight difference between the two. This much kg. Let this is your m. So you have number of these nucleons, and each nucleon has certain mass m, and the number of nucleons is mass number, that is your A is your mass number. So these are the total number of nucleons, and each nucleon is having mass m. So you can write A into m as the mass of nucleons. Now this is divided by 4/3. Okay, so I am taking 3 in numerator. 4 into pi. Pi is 22/7. 7 I am taking in numerator. Into r cube. And r can be replaced by r naught a power 1/3 and cube of this r cube. So here you have 3. So density comes equal to 3 into 7 into m a divided by 88 into r naught, and it is having value 1.2 into 10 to the power minus 15 whole cube, and a power 1/3 multiplied by 1/3, so it becomes a. You can cancel a from numerator and denominator. So density of any nucleus is free from its mass number. Mass number is cancelled. So you find that density is equal to 21 times mass of a proton or a neutron, and I have taken an average mass 1.67 into 10 to the power minus 27 divided by 88 into, here you have 10 power minus 15 power 3. So this is equal to minus 45. And 1.2 whole power 3. So this is a complete number, you can see. Density is free from mass number. And on simplification, density comes equal to 2.3 into 10 to the power 17 kg per meter cube. It is free from any another quantity. Density is a constant for all the elements. Density of nucleons inside nucleus of hydrogen, helium, neon, argon, any element of uranium, any element will be same. This is a complete number. So here you have one question related to density of nucleons. How density varies with mass number? The density varies directly to, you have given 4 options. Now here we find that it is free from any quantity. It is a complete number. Here you can see mass number is cancelled, and every other quantity, here you have mass of proton is a constant. Every other quantity is a constant. So density is free from mass number. It cannot be option A, cannot be B, or cannot be 3. Here you have in 4th option A raised to power 0. You know that any number, any quantity raised to the power 0 is equal to 1. So it is 1. 4th option actually is 1. So you can write density is proportional to 1. Your 4th option is correct. Question of this kind related to density of nucleus comes in your exam. So given the mass of iron nucleus as 55.85 unit and mass number A 56, find the nuclear density. Now let me first of all convert this mass into SI unit for calculations. Mass given is 55.85 unit, so it will be equal to, here we will be writing the value of 1 unit in terms of kg. So this is equal to 1.660539 into 10 to the power minus 27 kg. You need to remember some units, the value of 1 atomic mass unit in terms of kg. So you can just ignore these values. You can write only 1.66 for simplicity. So this is your mass. Now we know that the density of any substance is equal to mass divided by volume. And so this is equal to mass, nucleus is spherical, so volume will be 4/3 pi r^, and therefore density will be equal to mass divided by 4, and I am taking 3 in numerator. 3 into 4 pi, I am writing 22/7. 7 I am taking in numerator, and for r^, I am writing r0, mass number power 1/3, and whole of its power, here you have cube, so this is cube of the quantity. So from here you can write density of iron. Density of iron is equal to mass I have already obtained, 55.85, into value of 1 AMU into kg. This is your 1.66 into 10 to the power minus 27. And then in numerator you have 3 into 7. So this is equal to 21 divided by 88 into R naught. R naught has value 1.2 into 10 to the power minus 15 whole cube. And A, here the power will be cancelled, and mass number it is given 56. So now you have all the numbers here. You can simplify this, and the unit will be kg per meter cube. And on simplification you find that it comes nearly equal to, almost nearly equal to 2.3 into 10 to the power 17 kg per meter cube. So the same density of nucleons in any element is a constant. Now let us draw a graph between density of nucleus and radius of nucleus. So taking density on y-axis and radius on x-axis. We also know that radius is proportional to a square of principal quantum number, square of cells. So for heavy element, when you have more electrons, this number will be large because electrons are arranged as 2, 8, 18 in different cells. So for heavy element, this number of cells will be large, and so therefore this radius will be large. And so for heavy element, the graph will go to this larger distance, radius will be large. But we find that for all the elements, density is same. So graph will be of this nature. Here density is constant for large radius, then suddenly it falls steeply, and then it comes close to zero value of density. Now for elements of larger mass number, you have the graph of this nature for density of nucleons and radius of nucleus. Now for light elements, suppose you have hydrogen or helium, these number of cells will be deleted. You will have only one cell. So radius also, which is proportional to square of this principal quantum number, radius will be small. Now for small element, you will have radius only up to this, but density will remain the same as we have just obtained. It is nearly equal to 2.3 into 10 to the power 17 kg per meter cube. So you will obtain a graph of this nature. Now what is the radius of a nucleus? Here when you draw a line in between these two extremes, so up to this distance you have uniform density, and then you have sudden gradual fall of density after certain radius, and now find the mean value of this at this point, and this is called the radius of a nucleus. So you will find that if you have a nucleus, then in nucleus you will have a skin effect. you will have a dense nucleus inside. Here you have dense nucleus up to this length. Density is uniform density. Then density will reduce gradually. Here density is least and density is decreasing gradually. And radius is taken up to this length. From center up to the center of this gradual decrease. This is called radius.